Catastrophe on the air first and third Sunday, 7 p.m., W5FC.
I need to make myself very clear. If we uplink now, Skynet will be in control of your military.
But you'll be in control of Skynet, right?
That is correct, sir.
Skynet.
And does anyone need to use the repeater before we begin tonight? Skynet. This is Kilo Echo 5, India Charlie X-Ray. My name's Tom, and I'll be your net control for this session of the DARC Skynet. Skynet is a weekly net called every Saturday night at 9 p.m. concerning the subject of astronomy. Our purpose is to help amateurs become more familiar with the nighttime and daytime sky, astronomy, and space in general. This net is open to all amateurs interested in this topic, and we encourage your participation, comments, and suggestions for this net. Stations with priority or emergency traffic may enter the net at any time by using the post sign break break and your call sign. Is there any emergency or priority traffic? Please come now. This is a directed net, so please do not transmit without direction from net control. That would be me, and stations are reminded to ID at the end of their transmissions. This weekly net operates on this frequency, which, in case you hadn't guessed, 146.880 megahertz with a field tone of 110 decibel niner. Check-ins via Echo Link are also possible using the W5FC-R station ID or Echo Link node 37247. Tonight's topics, astronomy charts, pictures, and live audio links are also available online. Go to the club website, which is w5fc.org right now for a complete list. And remember to tell others about this popular net. All amateur operators are welcome. You need not be a member of any amateur radio club to participate. This net is 90 minutes long and it's structured in a number of different parts. I'll list them now. General announcements, Texas Astronomical Society of events where and when you can look through a telescope, National Space Society events, discussion topics this evening, what you can see in the sky tonight, or sometimes known as What's Up, a featured constellation or object, recent astronomical discoveries, I'll get it right, space exploration and space history, visible satellite passes over the next couple of days, astronomical Q&A in 73 rounds. We'll see if we get to all of them. We frequently don't, but that's okay. We'll start with short time check-ins. For your short time check-in, you'd like to be counted on the net. Please come now with your call sign, your name, and where you're transmitting from.
Is November 5, Whiskey Oscar India, William and Alan. Short time.
N5 WOI, William and Alan. Any other short time check-ins, please come now. All right, very good. William, N5WI, do you have anything for the net this evening? Any announcements or anything you'd like to bring? I don't know how long you are staying, but we'll get you right now if you have anything you'd like to present.
WI here. Actually, I just want to check in. I'll be lurking in the background, but have some other stuff I need to do. But appreciate you asking. N5WI, back to the net.
Just thought I would. You were the only short-time check-in, so you got called out direct, so no problem. Glad you're there, and hope you enjoy the net for as long as you can stay. Round general check-ins. That would be anybody who'd like to join us this evening. Please come now with your call sign, your name, where you're transmitting from. Here we go.
N5BB, Bill in Irving.
This is November 5 Alpha Bravo Alpha, Andre in Dallas.
P, Mike in
Richardson.
KF5, JHA, Chaz, Mesquite. It was nice seeing some of you at the Skywarn training today.
November Tango 5, Tango Mike.
Whiskey Bravo 5, Oscar Zulu Lima, Brenda and DeSoto.
Foxtrot 5, Zulu, Bravo, Lima, Bill, Farmers Branch.
Number 5, Oscar Foxtrot, Clay in Mesquite. All right, let me go ahead and get these checked in. There was, I think, a triple, so you may not hear your call sign. I will take another round immediately after this. N5BB, Bill and Irving. N5AVA, Andre in Dallas. KT5P, Mike and Richardson. K5JHA, Chaz and Mesquite. NT5TM, Tony in Dallas. WB5OZL, Brendan DeSoto. K5ZBL, Mr. Bill in Farmers Branch. OF Clay in Mesquite. I think that's a new call. Additional check-ins, please come now.
Whiskey 5, Golf, Juliet Tango, Jean from Carrollton.
Kilo Charlie 5, Oscar Zulu Tango, Carolyn and Louisville.
Alpha 5, Alpha Hotel, Robert and Richardson. Bill.
All right, there was one other double in there. Let's see, I got Whiskey 5, Golf, Juliet, Tango, Gene, and your location, Gene?
I'm in Carrollton.
Very good. Whiskey 5, GJT, Gene in Carrollton. KC5OZT, Miss Carolyn Louisville. AA5AH, Robert in Richardson. There was a second Carrollton call in there, I think. If you are that other person in Carrollton, please come again with your call sign and name.
This is Kilo Golf 5, Whiskey Victor Lima, James from Carrollton.
Very good. KT5, Whiskey Victor Lima, James in Carrollton. Additional check-ins, please come now.
Kilo 5, Kilo Tango X-Ray Kelly in Quinlan.
Kilo Bravo 5, Papa Victor Tango 10, Hazlitt, no traffic.
All right, let me get those two. I've got K5KTX, Miss Kelly in Quinlan. KB5, Papa Victor Tango, Ken in Hazlitt over Echolink. Okay, we got our first Echolink. I will now turn to Echolink, and anybody out there who would like to check in, please do so now. I'll give you extra time if you want to go by voice. If you don't have that, then go ahead and type in that you're there and you'd like to be checked in. Echolink only. We'll give you extra time.
November 5, Yankee Echo Oscar, Stephen, San Antonio, under the weather. Kilo Golf 5 Bravo Zulu Whiskey J near Weatherford.
Kilo India 5 Bravo November Papa Luis in Fort Worth.
All right, let me get those check-ins. I've got N5YEO, Stephen in San Antonio. Sorry you are feeling bad. KG5BZWJ near Weatherford. I got KI5 Bravo November Papa Luis in Fort Worth, and I've got K5JDW John in Norman. Okay, one more round. Anybody, anywhere, if you'd like to join us, please come with your call sign, name, and where you're transmitting from. Well, let's get this started. We'll begin with general announcements for this evening's net. They can be ham, astronomical, space, or of general interest to licensed hams. Please come out.
The 5, Tango Mike.
T5TM. Tony, you're the guy this evening. Go ahead.
Thank you, Tom. I'd like to remind everyone that we are under a dense fog advisory tonight. Please be careful if you have to drive anywhere, and remember to use your low beams in fog. This is not the last net of the night. We do have an Afterglow movie discussion net coming up at 10:30 p.m. We'll be talking about the 1966 TV movie, The Doomsday Flight. Last net of the weekend. We have a meeting on the air tomorrow at 7. And a races training net tomorrow at 8. The meeting on the air is an on-the-air informal meeting. If anyone would like to share what's been going on in their ham world, you don't have to be a club member to check in, and it's right here tomorrow at 7 p.m. Ham Fixin's net coming up this Monday on this repeater at 7 p.m. And if you can stick around till next weekend, we have a lecture and lab for you. If you can join us at the Dallas Medical Center, that's the northeast corner of Webb Chapel and LBJ, this coming Saturday, the 23rd at 10 a.m., you can build a multimeter of your own. Bring a soldering iron and, yes, $15, and you'll be able to build something that you could buy for only $5. But the whole point is that you'll have learned to build it, and that makes lecture and lab fun. Finally, 2 weeks from today is the Irving Ham Fest at the Betcha Bingo Hall in Plano. This is a Saturday-only flea market-style ham fest. It will be winding up by 1 p.m. on Saturday, so get out there early. If you can volunteer to help, please head over to w5fc.org and use the Contact Us form. We need volunteers for setup on Friday night, takedown on early Saturday afternoon, and taking tickets, we call it security, during the event. Volunteers get free admission and a free door prize ticket. So head over to w5fc.org and use that Contact Us. For more details about these announcements and other club activities, please check out w5fc.org. Just have a look at our posts for TechNet or Skynet. This is NT5TM.
County. Does anyone need any fills? Need any information? Please come with your call sign. All right, well, you're going to be in for a very special challenge when building this multimeter. First off, it's nicer than the one at Harbor Freight for $5. It really is a nicer meter. It did come with a battery. It didn't say that it would come with a battery. There's 10 of them. And here's the clincher, the best part. This is where working with friends during a lecture lab is particularly important. All the assembly instructions, which I just discovered today, are in Chinese. So this is going to be a most interesting build. We'll all work together to figure out which part goes where. It shouldn't be too bad, but it won't be as easy as it might seem. So you'll have a good time. Just bring $15 and correct change only. I don't have change on me. I think you'll like the meter. It's actually a little more robust than that Harbor Freight thing. Okay, let me go ahead and let me tell you about, well, let's see. Let me go to the Afterglow movie info. Okay, everybody listen in. You did hear that the Doomsday Flight was the movie. Here is a description. Captain Anderson adjusts the controls to his 797 aircraft. In the back of this amazing, as yet to exist aircraft sat passengers from every major 1960s TV show. There was Lou Grant, Steve McGarrett, Commodore Mendez, Barney from Mission Impossible, and that weird guy who hangs around failed Gene Roddenberry movies and a dozen more who probably shouldn't even be here as they would die in the first 5 minutes of most TV shows. Here they all were on Anderson's plane. The 797 wasn't. Somewhere in the baggage was a UPS package gone bad. Funny, thought Anderson. My last paycheck had Oceanic Airlines on the header. The day wasn't looking very promising. So join us for Pandemonium in the Skies in this Rod Serling, yes, Rod Serling penned the Doomsday Flight tonight at 10:30 p.m. So you can also watch it over on YouTube. Just type it in, 1966 with the title, and you'll find it. All right, do we have anyone from the Texas Astronomical Society of Dallas? Let's talk about the TAS. Please come up. Okay, don't hear anyone, but I'll go ahead and give a very brief announcement. Their meetings are held on the fourth Friday of every month at the University of Texas at Dallas campus in Richardson. The meeting begins 7:30 p.m. in the Science Learning Center, SLC, on campus. Remember to only park in lots H, I, or J. Parking anywhere else on the campus could result in a ticket, or worse, you don't want to have your car towed or ticketed. The meetings include programs presented by members or guest speakers, slideshow, current constellation of the month, and sometimes there's items for sale such as T-shirts, books, and other and observing aids. You can go to TAS of Dallas website, which is texasastro.org. The Texas Astronomical Society also hosts observing parties every Saturday night, beginning at sunset and concluding at 10 p.m. Central Time. Each week is a different location for observing, so make sure you get complete details for the Saturday night you wish to attend. Go to texasastro.org and the selection calendar is down for complete details. Star Party was scheduled for Hill. Unfortunately, it was canceled. Probably still cloudy out there, so probably not a good thing. But the calendar is updated this evening to let us know that the target was canceled. So there's a different location. Next week will be Stars on the Rock. That's held at the Shores Park in Rockwall, Texas. They do have a map there. Again, they go from 6 until 9 p.m. That's probably more correct than what I told you. So go to texasastro.org for additional information. All right, next up is National Space Society of Events and Activities, usually presented by Bill N5BB. Bill, do you have anything for us this evening? All right, I think he ran off for a minute. We'll find him later. He'll probably check in if he's got anything for us. Let's see here. I did want to mention that I did go to the National Space Society meeting this past Wednesday? I think it was. Saw Don Thomas. He was the astronaut, one of the payload specialists on STS-70, the Woodpecker mission, the one we talked about last week. That was pretty cool. Enjoyed that. He was a pretty funny guy, too. So every once in a while, National Space Society pulls out somebody with significance when it comes to space and space exploration. So I had a great time. Got his book signed by him and one of the patches. It was really a lot of fun. So that was my first National Space Society meeting here in Dallas. I was an original member way back. I think it was in the 70s that they started. But I probably should re-up. I bet you that's expired by now. Okay, let me go ahead and pause, and I'll ask any additional check-ins, and we'll get into what topic is this evening. Anybody else like to check in come now?
Number 4, Mike, Foxtrot, India, WB4MFI, Ted, Dallas, low power.
Got you in, Ted. This is not a regular. That's WB4MFI, Ted in Dallas. Okay, we have actually 2 topics this evening. We have a little change in our usual schedule, but that's okay. This has to do, it's actually an article. I wish I could vamp this, but I can't. I'm not that smart. I'm going to read you an article. It's really based on a number of other articles that have come up this week involving missing matter in space. It's not dark matter. It's just ordinary, everyday matter. Matter matters, you know. This came from dailygalaxy.com. That's an astronomy website. Here's what they said. Astronomers have spent decades looking for something that sounds like it would be hard missed. About a third of the normal baryonic, you try and say baryonic matter in the universe. New results from NASA's Chandra X-ray Observatory may have helped locate this elusive expanse of missing matter. From independent, well-established observations, the scientists have confidently calculated how much normal matter, meaning hydrogen, helium, and other elements, existed just before the Big Bang. In a time between the first few minutes and the first billion years or so, much of the normal matter made its way into cosmic dust, gas, and objects such as stars and planets that telescopes can see in the present-day universe. The problem is that when astronomers add up all that mass of the normal matter in the present-day universe, about a third of it can't be found. This missing matter is distinct from the still mysterious dark matter. The version of the Hubble's deep field image is shown. In fact, that's a picture I've got up, and you can go to the website and see it. It is kind of mysterious looking. In dark gray, you can see the new light that's been found around the galaxies in this field. That light corresponds to the brightness of more than 100 billion suns. It has taken researchers at the Instituto de Astrofísica de Canarias almost 3 years to produce this image of the universe ever taken from space by recovering a large quantity of lost light around the largest galaxies in the iconic Hubble Ultra Deep Field Telescope. One idea is the missing mass gathers into gigantic strands or filaments of warm, that would be temperatures less than 100,000 degrees Kelvin, and hot, temperatures greater than 100, well, that must be a mistake. It says the same thing, 100,000 degrees Kelvin. Well, you'll have to look that one up. Gas in intergalactic space. These filaments are known by astronomers as the warm, hot, intergalactic medium, or WHIM, W-H-I-M. They're visible to optical light telescopes, but some of the warm gas in the filaments have been detected in ultraviolet light. Using a new technique, researchers have found new and strong evidence for the hot component of the WHIM based on data from Chandra and other telescopes. If we find this missing mass, we can solve one of the biggest conundrums of astrophysics, said Ultraviolet Kovacs at the Center for Astrophysics. He says, and that's in Harvard and Smithsonian in Cambridge, Massachusetts. Where did the universe stash so much of its matter that makes up stuff like stars and planets and us? Astronomers use Chandra to look for and study filaments of warm gas lying along the path to the quasar, a bright source of X-rays powered by rapidly growing supermassive black hole. This quasar is located 3.5 billion light years from Earth. If the WHIM's hot gas component is associated with these filaments, some of the X-rays from the quasar would be absorbed by that hot gas. Look for a signature of hot gas and print it in the quasar's X-ray light detected by Chandra. One of the challenges of this method is the signal absorption by the WHIM is compared to the total amount of X-rays coming from the quasar. While searching the entire spectrum of X-rays at different wavelengths, it's difficult to distinguish such weak absorption features, actual signals of the WHIM, from random fluctuations. Kovacs and her team overcame this problem by focusing their search only on certain parts of the X-ray light spectrum, reducing the likelihood of false positives. They did this by first identifying galaxies near the line of sight in quasars that are located same distance from Earth as regions of warm gas detected from ultraviolet data. With this technique, they identified 17 possible filaments between the quasar and us and obtained their distances. Because of the expansion of the universe, which stretches out light as it travels, any absorption of X-rays by matter in these filaments will be shifted to redder wavelengths. The amounts of shifts depend on the known distances to the filament, so the team knew where to search in the spectrum for absorption from WHIM. Quote, our technique is similar to principle to how you might conduct an efficient search for animals in the vast plains of Africa, said Akos Bogdan, the co-author, who also from CFA. We know that animals need to drink, so it makes sense to search around watering holes first. While narrowing their search elk, the researchers also had to overcome the problem of faintness of X-ray absorption. So this signal by adding spectra together from 17 filaments, turning a 5.5-day-long observation into the equivalent of almost 100 days worth of data. With this technique, they detected oxygen with characteristics suggesting it was in a gas with a temperature of about 1 million degrees Kelvin. By extrapolating from these observations of oxygen to a full set of elements and from the observed region in the local universe, the researchers report they can account for the complete amount of missing matter At least in this particular case, the missing matter has been hiding in WIM after all. They say, we are thrilled that we're able to track down some of the missing matter, said co-author Randall Smith, also of CFA. In the future, we apply the same method to other quasar data to confirm that this long-standing mystery has been cracked. And that's from the Daily Galaxy, the X-ray the Chandra X-ray Center. They also have a website, obviously. Okay, that's what I had. I just thought I'd plug that in and mention it. It's all over the interweb. You'll find a number of articles and quoting the Chandra X-ray Center as well. I thought this one was probably the best articulated and in detail that it be of interest to this group. I am KE5ICX. I'm net control for tonight. Skynet. Let's see. I'm going to ask Chaz. F5JHA, do you have a what's up for us tonight?
Good evening, everyone. This is KF5JHA Chaz. My degrees in astrophysics. I actually work at Brookhaven Community College. I'm sorry. Thank you, Tom. On last week's Skynet, I told you about the moon occulting the stars of the open star cluster, the Hyades, which is the face of Mars full. This happened on this past Wednesday. The Hyades is considered the closest open star cluster to the Earth at only a distance of 157 light years. And because it is close to us, the Hyades has some fairly bright stars. Unfortunately, just like it has been almost every evening over the last couple of months, it was cloudy on Wednesday, and we did not get to observe the event here in DFW. We'll get another chance to watch the Hyades on the evening of March the 12th. So we'll talk about that again when we get closer to that. Last week, during Skynet, I also told you about an event on February the 17th when the moon would occult another open star cluster, M44, also known as the Beehive Cluster. This open star cluster is much further away from the Earth than the Hyades. It's at a distance of 577 light years. So the stars are fainter than the Hyades. So you will really need to use telescopes to observe this event on Sunday night. Plus, the moon is almost full, so it's going to be very bright against the background of the fainter stars. They might be difficult to see even with a telescope. Actually, since the forecast for cloud cover for Sunday night, I guess you'll need X-ray vision. That's the requirement for Sunday night's event. Just a reminder from last week, an occultation is when the moon covers up a star or planet from our view here on the Earth. Tonight, if you could see it, the moon is in between the first quarter and full, so it is at its waxing gibbous phase. And the moon is next to the bright star Pollux tonight as well. Pollux is the bright star representing the head of one of the Gemini twins. February 19th, the moon is February 19th, the moon is at perigee at a distance of only 356,750 kilometers. Perigee is when the moon is closest to the Earth in its orbit. Also, on February the 19th, the moon is full. When the moon is full, it is in the opposite part of the sky from the sun. So around full moon, the moon rises when the sun sets, and the moon sets when the sun rises. The moon will rise about 50 minutes after sunset the next night on February the 20th. Then another 50 minutes later on February the 21st. The same 50 minutes per day change happens with the moon's setting times as well. This changing of the moon's rising and setting times is the result of the moon orbiting the Earth. Compared to the background stars, the moon moves about its own diameter of sky per hour, which is about half a degree. In one day, 24 hours, the moon moves a little more than 12 degrees of angle through the sky. So in a little more than 27 days, about 27 1/3 days, the moon completes a 360-degree lap around the Earth. We call that an orbit. The moon is not at the same phase as it was 27 1/3 days before, because the sun has moved as well during the course of the month. So the moon needs to move another 2 days in its orbit to get back to the same phase. This is why the lunar phase cycle is 29.5 days. And that's why we call it a month, because it takes about a month to go from new moon back to new moon. We call it a month rather than a month. The moon phases, the moon passes close to the bright star Spica. Yes, Tom, that's Spica. In the morning sky on February the 23rd. The moon will be at its third quarter phase on February 26th. On February 27th, the moon is going to be very close to the planet Jupiter early in the morning sky. And finally, the moon is close to Saturn on March the 1st and close to Venus on March the 2nd. Reminds me of a question. Does the moon take care of its hair? Well, first, he clips it. I should have saved that one for the next lunar eclipse. Now, looking at the planet, you'll find Mars halfway up in the western evening sky after it gets dark. It's a pale orange object. Mercury is very low in the western sky in evening twilight and will remain low in the western evening sky through the end of February. The other three planets are visible in the morning sky. The southeastern morning sky, going from left to right, you will find Saturn, then Venus, then Jupiter. Venus, of course, is the brightest thing in the sky other than the sun or the moon. But on Monday morning, February the 18th, Venus and Saturn are in conjunction. A conjunction just means that they are really close to each other. After February the 18th, Venus and Saturn switch positions, and Saturn is lower in the southeastern sky, and Saturn is in between Venus and Jupiter in the early morning southeastern sky. So, I just want to know out there in Radio Land if any of you have any questions or need a fill for any of this information. Sun, and some people do see a hair in the moon, and a woman, and, well, okay, there's a lot of things they see in the moon. Okay, then that must be it. This is Chad, KF5, JHA, and that's all for this week. What's up? Back to Tom, neck and roll.
Thank you, Chaz. This is KE5ICX, and you can always count on Chaz to be a very punny guy. And then Skynet. Let's see. Let's go ahead to the next section. We are going to skip constellations this evening. We'll get back to that next week. So we do have a continuing series that Mike, G5P, has been talking about quantum mechanics. He's making it simple for us. Tonight he's going to talk about the ultraviolet catastrophe. So Mike, KG5P, what do you have for us this evening?
Okay, thank you, Tom. It's KG5P. Well, I can't say I'll make this simple, because it's not. I mean, it took the best minds for hundreds of years to get even where as far as we've talked to up until tonight, which is mostly the history. Tonight, I'd sort of like to finish out the history. We're going to talk about the resolution of the so-called ultraviolet catastrophe, and we'll finish up with, I hope if I can get to it, we'll finish up with what Max Planck did to resolve this. And Max Planck was really considered the father of modern quantum physics, and then from then on, it's all downhill, right? So we pick up how how this called the ultraviolet paradox came to be. And if it worked out, if the ultraviolet paradox, whether it was a paradox, is because what they calculated would have predicted the end of the world. And since obviously that didn't happen, there's must be something wrong with that prediction because it didn't match what they observed. I didn't time this machine out here. All right. So consider an empty box, an empty body with a tiny hole in it that contains cavity where we inject a beam of electromagnetic waves, say light waves, through this tiny hole. Now, think of it, just imagine this is your refrigerator. And you take your Black & Decker drill and you drill a hole through this side. And you stuck a flashlight into that hole and you're injecting, say, 1 photon at a time in there. Also say that the walls inside this cavity are quite good but not perfect reflectors, so that the light rays one side of the cavity bounce back and forth many times. So you got all this light coming into there, but it can't get back out because it can never find its way out through this little hole, kind of like a roach motel. At this point, it becomes clear why every material object in thermal equilibrium with its environment can, despite a somewhat misleading terminology, can be considered a body. Okay, in this context, don't consider the black with the color or the brightness of an object. The sun, for example, can be considered a black body in a sense that physicists mean, since it's an object which maintains its temperature over a long period of time. And the energy which is emitted into outer space is replaced by the energy that it produces in its inner core. So physicists of the 19th century considered the black body radiation cavity as a model that was supposed to describe the electromagnetic energy content of any physical body with a finite temperature. Okay, basically what this said was they came up with a formula that said the intensity of the electromagnetic radiation in our body is this function of its temperature or wavelength, or temperature and wavelength, or color, and that's to be considered the energy density of radiation per unit frequency, the volume. So that's another term you're going to hear is radiation density. So this radiation, when in a stationary state, was modeled with what physicists call standing waves. And as ham radio operators, we all know what standing waves are on antenna feed lines. These behave like electromagnetic waves in a box which are reflected back and forth and do not interfere with each other destructively, only constructively, building oscillating but stable wave structures. So standing waves are precisely all those that have only the wavelengths that match the cavity walls with a zero amplitude. As an analogy, you think of a rope attached to a doorknob. At the other end, you're swinging this rope up and down, and you're producing a mechanical wave that propagates along the rope and is reflected back to you from the doorknob. Okay, and I've got a picture that I sent Tom, and it shows which could be a rope or a wavelength. If it's inside a refrigerator, it doesn't have to be a rope. Or it could be a light wave too. But the first one shows it to be a half wave. The second picture is 2 half waves or a full wave. The picture is 3 half waves. The fourth picture is 4 half waves or 2 full waves, and so on up to 6. But what they have in common is that each node is a half wave length apart, and one end is attached to the doorknob, and the other is you're holding your hand and you're swinging it up and down. So this reflected wave will interfere with the incoming wave, and an interference phenomenon will occur. And this will only occur, you do the doorknob trick, that this only occurs for some precise oscillation frequency where you can create a stable oscillation pattern. Therefore, these standing waves can only exist at specific wavelengths, which are called modes. Only at these mode frequencies can they interfere with themselves constructively. For other frequencies, you observe disordered oscillations. So not every kind of electromagnetic wave can be considered or can be contained in a cavity in a stationary mode. Only those that match the right frequencies. So you can see that even these conditions, the infinite number of such nodes can fit between the walls. Okay, I only showed 6 nodes in my example here, but in principle there's no other limit. The number of modes can be as virtually large as we wish. Pick a number. If we approach an infinitely small wavelength, that is infinitely high frequency, we can accommodate an infinite number of modes. Now, the problem with this model is that in classical physics, there's no reason to assume that one electromagnetic mode should be considered more privileged than the others. This means that if we wait long enough until the system is in a thermodynamic equilibrium, the inside is equal to the outside temperature, energy will be exchanged and distributed among all the nodes equally until they eventually attain the same average energy. There's no reason to believe that one mode should oscillate with more energy than the other. The cavity's energy, or the energy inside of your refrigerator, will be exchanged and distributed among all the modes equally until they finally attain the same average energy. There's no reason to believe that one mode should oscillate with more energy than the others. The energy content would be distributed equally over the modes. This is what physicists call the equipartition theorem. Okay, now modes interact with the particles on the walls of the enclosure and those within its volume. The particles making up the container can be seen as little springs that oscillate back and forth at different frequencies, but are harmonically related. They're so-called harmonic oscillators, which absorb and re-emit energy from and back to the modes so that the energy exchange among the modes itself can occur. Then it seems logical to assume that this equilibrium average energy of the modes depends upon the amount of the body's thermal energy, which in turn is determined by its temperature. In the picture, each mode can, in principle, oscillate with any conceivable energy. There's no upper or lower boundary, and there's no reason to believe that any value in between could be considered forbidden, at least in classical physics. Okay, now here we get the good stuff. As tiny as this average oscillation may be, if the cavity is supposed to contain an infinite number of modes, and since there's no upper limit to a frequency that a mode can acquire, each mode has the same small but non-zero energy. We have to conclude that the cavity as a whole contains an infinite amount of energy. So think about that. The energy in each mode is small, but it's non-zero, but we have an infinite number of them. The number of anything that's greater than 0 is going to be a pretty big number. So obviously something's wrong here. Even if this result was immediately implausible, nobody knew for sure how to resolve it. This was until Max Planck came along, that is, and he found the best way out of this dilemma. Okay, this demonstrates what's called the ultraviolet catastrophe, modeling that the energy density of radiation of a black body at a temperature that diverges at high frequency from what was observed. It was called ultraviolet since the ultraviolet light makes part of the upper frequency spectrum of a light where the energy diverged just to diverge. in the ultraviolet spectrum, the energy actually tips down, whereas in this model, it goes up infinitely. So Max Planck came along. It was in 1905, and he solved this interesting little state of affairs. Max Planck was working on his PhD dissertation, and he entered a couple of fundamental and revolutionary hypotheses into this description of this black body model. First, he proposed to replace the arbitrary energy value of each mode, or harmonic, with integer multiples with discrete energy. And this was the energy is equal to the wavelength times a constant called Planck's constant times n, where n is the number of frequency modes. Okay, what Planck told us that in an electromagnetic field, this black cavity must be composed of modes of particular frequency taking energy values such as 1, 2, 3 of the base mode. So it's like 1 times the frequency times Planck's constant, or 2 times the frequency times Planck's constant. You could not have a value in between such as 1.5 or 2.7 or something like that. The modern textbooks associated as n modes in the cavity with n number of particles called photons. However, the term photon didn't exist until a little bit later when Einstein came along, when he described the photoelectric effect. So this idea to replace continuous with discrete energy modes is not entirely a new concept. It was already known that atoms absorb and emit light only at specific wavelengths, not through a continuous spectrum. Almost done. Okay, the second hypothesis that Planck introduced was to consider all modes equally probable. This was not entirely a new idea either, but this match between Planck's theory and what was now observed solved the problem of the ultraviolet catastrophe. He didn't have an infinite number of modes, might have only had like my example 6. And the sixth one didn't contain as much energy as the fifth one, and so on. And this was determined experimentally, by the way, too, also by measuring radiation from different bodies at different temperatures. So Planck's spectral curves do not depend upon the type of material, but from the temperature. And that was a fact that was just then realized. Now, to sum things up, what this really did was give us astronomers a great tool for measuring the temperature of distant stars. There's no need to travel physically to a star light years away with a thermometer. All we have to do is measure its spectral curve that Planck provided for us, and we know its temperature by just fitting it with Planck's equations. And what I'm going to do next time is get into what Einstein won the Nobel Prize for, which is not his theory of relativity like other people think it was, but it was photoelectric effect. And after that, quantum mechanics took off. So I hope this made a little bit of sense. Again, if it doesn't, don't worry too much about it. It's difficult concepts, and the best minds on the planet struggled with it over for a long time, and they still are. So anyway, thanks, Tom. That's my spiel for tonight. Back to KH5P.
KG5ZIX.
Okay, thanks, Mike. And I think I got a freaking stationary. It's not on my list. Kilo Golf 5 Zulu India X-ray, I think it was. Checking in. Do you have a question? Either way, I'm going to check you in. Go ahead.
Yes, sir. I was listening to that very fun guy about the space stuff, and I was kind of curious about. I was quite impressed about his knowledge, but he talked about the temperature here compared to the temperature way out there, and I was wondering if that was the simple ratio and proportion equation. Where it's like if the temperature here and the temperature there, and a ratio and proportion thing. I was just kind of curious about that. No, it didn't live in my head, but that's kind of what came into my mind. KG5ZIXO in Wiley.
Okay, Joe, well, let's find out. He's way above me, so I don't even understand your question, although maybe Mike does. But I've got you checked in. Mike, KG5P, do you want to answer that question?
Okay, Tom, KG5P. Yeah, sure. Okay, last week we had that diagram. It showed one of this was like a graph, and on vertical axis we had the intensity, the electromagnetic wave, and on the right we had the wavelength on the y-axis. So if you go all the way up, the wavelength would be 0 or something infinitely high. As you go to the right, the wavelength would get lighter. Okay, and then there was that curve, and I'm trying to describe it. It's hard to describe it. You really have had that picture. But remember, the curve, it went up for a while, and then it kind of flipped over and came back down. And sort of toward the left center of the curve was visible light. To the left of that was the ultraviolet. Well, if you start out with a long wavelength, which is on the far right of the graph, and start going towards the shorter wavelength on the left, what would happen is the intensity would go up and go up and up and up and up until it finally reached the maximum, and then it would turn around and start coming back down. And that's what Planck showed us. And before Planck came along, this graph, which is on the left, it keep going up, and the shorter the wavelength went, the higher the intensity went. And finally, the intensity would be at an infinite amount, and besides violating the second law of thermodynamics, the world would come to an end because all this energy would destroy the universe. But it didn't do it. So I have to refer you to that graph, or if you go in and Google ultraviolet catastrophe, look at the pictures, the images, you'll see it. It's just that after the wavelength goes up to a certain, or goes to a certain point, and the frequency goes up, which means the wavelength goes down, that intensity is going to mix out, and then it's going to start coming back down again. And I don't believe in actual thing that is that. I'm not aware of it. Perhaps Chaz does. But that graph pretty much explains it. And again, if you want to see the graph, we had it last week, but just going to Google ultraviolet catastrophe, and then you'll see that it's called the first. It's called the Rayleigh-Jeans limit. It is the first graph that keeps going up until infinity, and they found out Rayleigh-Jeans. That didn't work. Planck did, because that graph doesn't go that way. It comes back down. I hope that answered your question. If I had a picture, it'd be a lot easier to show you. Back to that KG5E.
Well, thank you for the response. I can't make sure I'm not stepping on somebody. It seems like I'm cool. I was talking about temperature on planets. So there's a calculation, and I don't have that in front of me. There's a radius from Earth to the Sun and Mars to the Sun. Those two radiuses. So if the Earth is series. I don't have the paper with me, but what would Mars be? You know, with those three parameters, you should be able to figure out that. I would figure it out with me. So the distance from here to the sun, and the distance from Mars to the sun, and temperature here, should be able to figure out the temperature at Mars. It's called a ratio and proportion. And I don't have these paper in the calculator. I'm just kind of curious about that. Is that a dumb question?
Oh, okay, well, no, I mean, yeah, I think you're talking about the inverse square law. I mean, that's got nothing to do with what we're talking about here, but like the distance from the Earth, see Mars was twice the distance from the Sun that the Earth was. I mean, it's more than that, but we'll just say twice as much. For the example here, it would receive 1/4 of my light. Now, that doesn't necessarily mean temperature, because there's other factors involved, but it's going to receive 1/4 as much radiation because it's 4 times away. If it were 3 times away, it would receive 1/9 as much radiation. That's the inverse square law, is what you refer to.
Well, I thought it might be a similar ratio and proportion calculation, but I didn't think about it. Like in this good here. You know, well, I'm a machinist, so in the machinist world, you can kind of ratio and proportion everything up, but I didn't back to the radiation and sunlight, so it's just kind of got my mind wandering.
Well, it's not a straight proportion. Twice as far doesn't mean that it's half as much light. It means it's 1/4 as much light because it's an exponential type of proportion. It's not x, it's squared. So, what Planck told us is that, for instance, on a Hertzsprung-Russell diagram, you can look at, say, the main-sequence stars, like the Sun is one, and on the Hertzsprung-Russell diagram, there's a relationship between the color of the star and its temperature. We've talked about this before too, but that's been well known in astronomy for years. There's a relationship between temperature and color. The hotter suns, or the yellow or blue suns, have hotter temperatures, and the red ones have cool temperatures. So I think you're more referring to the. But this thing that Planck taught us would be more appropriate for speaking about the temperature of a star, not so much its distance. Distance refers to the inverse square. Like Pluto doesn't get very much light. We'll say it's 20 times. I'm not sure exactly what the distance is, but we'll say it's 20 times as far away from Earth as the Sun. That means it'll receive 1/400 as much light, because that's 20 squared. But that inverse square law, it's important. It's an important rule in physics that that has to do with radiation received, and not necessarily its temperature or color. So I hope that answered your question. We could probably talk about this at a later if you wanted to. I think Tom wants to move on. So that was sort of what you were looking for. I had K5P.
Hey, yeah, thank you. You have to back me out a lot. I said I'm a machinist with it. It's all standard known numbers. And there's no, I guess you would say, differences in sun power or sunlight and stuff, so that's another variable that I don't have to deal with. Anyway, I really enjoyed listening to you talking. I'll probably hear you a lot more. So I'll clear the channel off and let you get along with what you're going to do. KG5ZIX, Joe and Wiley, I'll be clear after the phone.
Okay, well, thank you very much for the got some more stuff, so we'll get back and get back on the track here. Back to you, Tom. KG5P.
All right, thank you guys. I appreciate it. And Joe, you're welcome to the net anytime. Okay, we do indeed have to move on a little bit here. We're mostly on schedule. Let's see. Next up, let me go ahead and ask your check-in sound. Move on to the next section of the net. Anybody else join us, please? When you call where you're transmitting, I will put you on the list.
Kilo Golf 5, Whiskey Golf Hotel. This is Nick and Carol.
I've got KG5 Whiskey Golf Hotel, Nick over in Carrollton. Boy, we got a large contingent out of Carrollton tonight. And this is KE5ICX Net Control for tonight. Skynet. Next up, recent astronomical discoveries. Miss Brenda, BB50 said, what do you have for us this week?
This is WB50. This article is entitled A Nearby River of Stars. Astrophysics publishes the work of researchers from the University of Vienna who have found a river of stars as far stream in astronomical parlance in most of southern sky. This stream is relatively nearby and contains at least 4,000 stars that have been moving together in space since they formed about 1 billion years ago. Due to its proximity to Earth, the stream is a perfect workbench for the disruption of clusters, measures the gravitational field of the Milky Way, and learn about coeval extrasolar planet populations with upcoming planet-finding missions. For the research, the authors used data from the ESA Gaia satellite. Our almost galaxy, the Milky Way, is home to star clusters of variable sizes and ages. We find many baby clusters within molecular clouds, fewer middle-aged and old-age clusters in the galactic disk, and even fewer massive old globular clusters in the halo. These clusters, regardless of their origin and age, are all subject to tidal forces along their orbits in the galaxy. Given enough time, the Milky Way gravitational forces relentlessly pull them apart, dispersing their stars into the collection of stars we know as the Milky Way. Most star clusters in the galactic disk disperse rapidly after their birth, and they do not contain enough stars to create a deep gravitational potential well, or in other words, they do not have enough glue to keep them together. Even in immediate solar neighborhoods, there are, however, a few clusters with sufficient solar mass to remain bound for several 100 million years. So in principle, similar large stream-like remnants of clusters or associations should also be part of the Milky Way disk, says Stefan Mengask, lead author of the paper published in Astronomy and Astrophysics. Thanks to precision of the Gaia instrument measurements, the authors can measure the 3D motion of stars in space. When carefully looking at the distribution of nearby stars together, a particular group of stars as yet unknown immediately caught the eyes of researchers. With a group of stars that showed precisely the expected characteristics of a cluster of stars born together but being pulled apart by the gravitational field of the Milky Way. Identifying nearby disk streams is like looking for the proverbial needle in a haystack. Astronomers have been looking at and through the new streams for a long time and covers most of the night sky. But in reality, it is there and it is huge and close to the sun, says Alvarez, second author of finding a cluster home is very useful. It means they are not too faint nor too blurred for further detailed exploration as astronomers dream. Due to sensitivities of the Gaia observations, their selection only contained about 200 sources. An extrapolation beyond these limits suggest this stream should have at least 4,000 stars, thereby making the structure more massive than most known clusters in the immediate solar neighborhood. The authors also determined the stream's age to be around 1 billion years. As such, it already has completed 4 full orbits around the galaxy and have time to develop the stream-like structure as a consequence of gravitational interaction with the Milky Way disk. As soon as we investigated this particular group of stars in more detail, we knew that we had found what we were looking for, a coable stream-like structure stretching for hundreds of parsecs across a third of the entire sky, says Verena Fernkrantz, co-author and master student at the University of Vienna. It was so thrilling to be part of this new discovery, she adds. This newly discovered nearby system can be used as a valuable gravity probe to measure the mass of the galaxy. With follow-up work, this stream can tell us how galaxies get their stars, test the gravitational field of the Milky Way, and because of its proximity, become a wonderful target for planet-finding missions. The authors hope to unravel even more such structures in the future with the help of the rich Gaia database. The other article is entitled Tidal, that's T-I-D-A-L, Tails, T-A-I-L-S, the beginning of the end of an open star cluster. In the course of their life, open star clusters continuously lose stars to their surroundings. The resulting swath of tidal tails provides a glimpse into the evolution and dissolution of a star cluster. Thus far, only tidal tails of massive globular and dwarf galaxies have been discovered in the Milky Way system. In open clusters, this phenomenon existed only in theory. Researchers at Heidelberg University have now finally verified the existence of such a tidal tail in the star cluster closest to the Sun, the Hyades. An analysis of measurements from the Gaia satellite led to this discovery. Open clusters are collections of approximately 100 to a few thousand stars that emerge almost simultaneously from a collapsing gas cloud and move through space at about the same speed, owing to a number of influences. However, they do begin to disperse after a few 100 million years. Among the factors working against the gravitationally bound stars is the tidal force of a galaxy, which pulls the stars out of the cluster. Tidal tails then form during the movement of the star cluster through the Milky Way. It is the beginning of the end of an open star cluster. Together with researchers from the Max Planck Institute for Astronomy in Heidelberg, scientists from the Center for Astronomy of Heidelberg University have detected this phenomenon for the first time in the Hyades, one of the older and best studied open star clusters in the Milky Way system. They studied the data published in April 2018 from the Gaia satellite, which has been systematically mapping the heavens for 5 years. Rather than taking direct photographs, Gaia measures the star's motion and position. From this data, the Heidelberg astronomers identified 2 tidal tails of the Hyades with a total of approximately 500 stars extending up to 650 light years from the cluster. Dr. Siegfried Rosser of the Königsstuhl State Observatory of the ZAH explains that one of the tails precedes the open star cluster and the other follows it. Our discovery shows that it is possible to trace the trajectories of individual stars of the Milky Way back to their point of origin in a star cluster, states Dr. Rosser. The astronomer believes that this marks the beginning of many significant discoveries in galactic astronomy. Apart from the Heidelberg astronomers, the team of researchers from Vienna also discovered the tidal tails of the Hyades. Okay, that's it. They're both from ScienceDaily.com. Back to net, WB50ZL.
Thank you, Miss Brenda. And this is KE5ICX. I'm net control for tonight's Skynet. Let's move on to space exploration and space history. Tony, NT5TM. You got a bunch of stuff for us this evening. Bad.
Thank you, Tom. I will try to do my best to focus on the highlights. Of course, the most important space exploration news this week was the end of the Mars Exploration Rover mission, with the failure of the second rover Opportunity being declared by NASA this Wednesday. The last successful contact with Opportunity was back on June 10th, 2018. After more than 1,000 ground and space-based attempts to regain contact, NASA announced that the mission was over. Opportunity landed on Mars on June 24th, 2004, after taking only 34 months from build to launch. And it survived far longer than its 90-day lifespan. It traveled 28 miles, took 224,000 pictures, and found some of the first proof that liquid water had existed on the surface of Mars. For me, and I think for many people who follow science and science news, this was an especially poignant failure. Many of NASA's most famous missions were launched before we were born, or when we were too young to remember them. But this probe was launched before I was 30, and heck, now I'm middle-aged. There has always been an opportunity exploring Mars, but not quite. Journalist Jacob Margolis earned a bit of internet fame by translating its last telemetry frame as "My battery is low and it is getting dark." Follow-up interviews with project scientists suggested this was not even quite bleak and sad enough. A better translation might have been, "My batteries have failed and I cannot find the sun." For all the probe's batteries were below their minimum allowed state of charge, and nothing, not a sun sensor, not the solar panels, could tell day from night. The sandstorm on Mars was just that severe. If you would like to read perhaps two of the most poignant comics ever published, look for the letters XKCD, that's X-Ray Kilo Charlie Delta, it's the name of a comic, XKCD and Spirit, and XKCD Opportunity. One cartoon was written for each on the loss of the Spirit and Opportunity rovers, and they're both a good summary of how many people feel about those missions. On a happier note, because Chuck is still with us, 1923, on February 13th, Brigadier General Charles E. Yeager was born. He was one of our most famous test pilots, the first person to have a well-documented trip past the speed of sound. He flew every pioneering model of rocket plane in the 1950s. By the 1990s, he'd flown 201 types of military aircraft and had more than 14,000 flying hours. He was famously portrayed in The Right Stuff as accepting only his meager military pay, although once he finished his Air Force career, he endorsed pretty much everything from spark plugs and underwear to, I don't know, probably Velveeta, although I haven't found a Velveeta commercial with him in it. On February 11th, 1952, a very influential series of articles appeared in Collier's Magazine, a weekly news magazine of the day. Man will conquer space soon. These were papers from the first symposium on spaceflight by Wernher von Braun and others that were published as popular news articles with beautiful illustrations by famous science fiction effects artist Chelsea Bonestell. These articles might have seemed like, well, just something in the popular press, but they were enormously influential. They persuaded politicians that space was serious and practical. They persuaded voters to support those politicians, and they motivated an entire generation of engineers to forsake cool fields, supposedly, like propeller aircraft and automobile design, and take up their careers in the aerospace industry. Some of those engineers were probably with us in 1997 when, on February 11th, Space Shuttle Discovery was launched on the second Space Telescope Hubble servicing mission. They had a spectacular night launch, rendezvoused with the telescope, and made 5 grueling spacewalks to renovate the Hubble. This mission achieved the highest altitude ever achieved by a shuttle, 335 nautical miles, about 600 kilometers. On February 11th, 2015, Discover, that's a word with few vowels, DSCOVR, was launched by NASA. This is, and was, and remains the Deep Space Climate Observatory. It faces the Earth from a great distance on one side and gathers whole hemisphere data about atmospheric gases and what's called the radiation budget of Earth. That's a complicated term for how much heat arrives and how much heat leaves, kind of important in contemporary science. With the instruments that face the other way, it provides advance warning of coronal mass ejections and solar storms. February 12, 1961, Venera 1 was launched. This was the first spacecraft to fly by Venus. Note that it was not the first spacecraft to return useful data from Venus. The Soviet Union had a big success with their new Molniya booster. That's the word for lightning. It restarted in orbit, which was in 1961 by no means a given that was even possible. However, after a week in space, something went wrong. No more telemetry, no more control. The spacecraft whooshed past Venus, but conducted no useful observations. In 2000 and 2001, the Near-Earth Asteroid Rendezvous mission, known as Near Shoemaker, had two milestones. First, it achieved orbit around the small asteroid 433 Eros, becoming the first spacecraft to orbit an asteroid. It's hard. They have almost no gravity. A lot of them you could escape by throwing a baseball hard. You have to be very precise to orbit something like that. Then on February 12, 2001, it became the first spacecraft to land on an asteroid. Now, this was not a lander. This was a deep space probe, big, fragile, covered in gold foil, with big, easily broken solar panels. But they very carefully slowed it to a speed of somewhere between 1 and 2 meters per second, 1.5 and 1.8 meters per second, and it was actually able to land on the asteroid, and they were able to successfully reconfigure one of its instruments to conduct detailed spectroscopic observations of the asteroid's surface. For a deep space probe, that's pretty cool. Soviet space probe Luna 20 was launched on February 14, 1972. This was the second of 3 Soviet probes that landed on the moon and returned small samples of moon rocks to the Earth. They were trying to compete with the Apollo program, although it would take an awful lot of tiny 30-gram dust samples to equal the well-selected rocks brought back by the Apollo astronauts. On February 14th, 1990, Voyager 1 took its final pictures. These were the last pictures taken by any probe in the Voyager program. The cameras and their heaters were then turned off. This was the family portrait, sometimes known as the portrait of the planets. It was an image of the solar system taken from a distance of about 6 billion kilometers. It featured individual frames of 6 planets and a partial background indicating their relative positions. It was 60 frames, and it's perhaps best known for the tiny, tiny picture of the Earth, a pale blue dot suspended in a sunbeam like a mote of dust. Something much bigger than dust, much bigger and louder and more destructive, struck the Earth on February 15th, 2013. This was the Chelyabinsk meteor. It was an Earth-grazing meteor. It had a very high speed, and it struck the atmosphere at a very shallow angle. This let it explode like an atomic bomb over the town of Chelyabinsk. This produced a bright flash, a terrible smell of rock, and a cloud of hot gas and dust. The bulk of the energy was absorbed by the atmosphere, but a lot of energy reached the ground. Thousands of windows were shattered. Part of a building collapsed. It was a factory, and about 1,500 people were badly injured enough by flying glass to seek medical treatment. Now, it might seem not so bad. 7,200 buildings lost their windows in 6 cities. What are some windows? temperature in Russia in February. It was cold. This was actually a national emergency. Schools had to be closed. People had to seek shelter. When it has a high of 14 degrees Fahrenheit, you can't just tape a garbage bag over your window. You have to have the building repaired. It was quite a big deal. This was certainly the most dangerous and destructive meteor impact since the 1908 Tunguska event, and really the only known meteor encounter with Earth to produce a large number of injuries or substantial property damage for things we cared about as opposed to wilderness. Finally, on a much less destructive note, on February 16th, 1965, Pegasus 1 was launched. This was a development launch in the Apollo program. It used a Saturn I vehicle whose real job was to carry a boilerplate Apollo command module into space to launch a special satellite built into the Apollo service module, or where it should have been. This was a satellite to detect micrometeoroids. Everyone assumed that small meteoroids in space were rare, but no one knew how rare or common they were. So the satellite had big wings, which were full of little meteor detectors. It was the 8th launch of a Saturn rocket, and it verified that indeed tiny sub-dust grain-sized meteors were common, but meteors big enough to damage an Apollo spacecraft were quite rare. So thank you very much. This is NT5TM. I know we'll all be thinking about Opportunity and Spirit, but they did a great job, and there are more Mars probes coming up that are very exciting. NT5TM.
Good. Thank you, Tony, for that excellent report. A lot of really interesting stuff happened this week, and appreciate you sharing it with us. This is KE5ICX. I'm net control for tonight's Skynet. We are almost done with this net. I'll take final check-ins. If you'd like to join us this evening, please come now with your call sign, your name, where you're transmitting from. Well, we'll just close it out. Tonight we had 23 hams checked in, including myself. Thanks to all who checked in this evening. We hope to join us here next week and every Saturday night at 9 p.m. To discuss astronomy, space, and space exploration on this net. The sky is never the limit. We're also looking for net control stations for this and all the DARC nets. If you'd like to try your hand at it, contact any of the net controls or send an email to nets, N-E-T-S, at w5fc.org. You can follow topics and discussion about this net and astronomy in general on Facebook and Twitter, as well as our audio and video streams, video archives, and other useful internet resources by going to w5fc.org at the conclusion of this net. Until next Saturday night, this is Kilo Echo 5 India Charlie X-Ray. Tom and I will be closing the net at 22:28 local time. 7-3, everybody, and enjoy the evening discovering the universe. We'll be back here in about 5 minutes or so to start the after-glow movie net. We'll be talking about the Doomsday Flight, a Rod Serling penned made-for-TV movie from 1966. So we'll be back in 5. This is KE5ICX. I'm clear.
Does anybody want to use the repeater before we begin the next? This is Whiskey Bravo 5, Oscar Zulu Lima. My name's Brenda, and I'm going to be the net control for the Afterglow Net tonight. We're going to be discussing the movie, The Doomsday Flight, a 1966 made-for-TV movie. First, I'm going to call on KE5ICX to give us a synopsis of the movie. Go ahead, Tom.
Thank you, Brenda. I exhaustively researched this film. I typed in The Doomsday Flight, 1966, in the word wiki, and came up with this very heavily researched item. So this is what they say. The Doomsday Flight is 1966 television thriller film written by Rod Serling. Yep, that Rod Serling. And directed by William Graham. The cast included Jack Lord, Edwin O'Brien, Van Johnson, Catherine Crawford, John Saxon, Richard Carlson, and Ed Asner. You recognize all those names from, all but one, from television or movies. Let's see. Next up, this is what they say on the plot. A Douglas DC-8 airliner described in the movie as a 797 airliner on a regular flight departs from within the Los Angeles Center when a bomb threat is made to the airline company to whom the plane belongs. It is later revealed that it is an aneroid bomb equipped with an altitude-sensitive switch and will detonate if the plane lands. Several attempts to find the bomb on board the flight, including tearing open several areas in the cabin and cockpit, are unsuccessful. The bomb threat caller telephones again from a bar, and the bartender realizes that he is who he is and tries to call the airline to save the passengers and crew. Bomb threat caller suddenly dies of a heart attack without identifying the location of the bomb on the plane. Faced with a fuel shortage, the captain then comes up with the idea to land at Stapleton International Airport in Denver, Colorado, which is above the destination altitude. In the end, the bomb is discovered where it was least expected, in the pilot's chart case. Short and to the point, a couple of things in here. For the production, the film premiered on NBC TV in the United States on December 13, 1966. It was released theatrically in cinemas in other countries around the world and distributed by Rank Organization in the UK. One comment, it says the movie led to copycats who would call airlines and claim to have similar bomb aboard a flight. A notable attempt was aboard a Qantas Airlines flight in 1971 when the caller claimed to have placed such a bomb. The man actually placed the bomb at a Sydney airport, leading officials to take the threat seriously and pay out $560,000 to the person. In 1971, the Federal Aviation Administration urged television stations in the United States not to air the film on the basis that the film could inspire other emotionally unstable individuals to commit the same or similar acts as the villain in the film. So that's it, short and sweet this evening. Back to you, KE5ICX.
Okay, well, we're going to take check-ins now. We'll start with low power short time. And if you'll give us, please, your call, your name and your QTH, and whether or not you have seen the movie. So please come down.
Number 5, Hotel Yankee Papa, Tom and Irving. Yes, we saw it.
Five, Killer Golf 5, Papa, Mike and Richardson. Yes, I saw it.
Echo 5, India, Charlie X-Ray, Tom and Melissa. Yep, I saw it.
Kilo Golf 5, Zombies Need Jobs. And yes, I saw the
Charlie 5, Oscar Zulu Tango, Carolyn in Louisville, and I saw the movie.
Number 5, Bravo, Bravo, Bill in Irving. I did see it.
Kilo, Foxtrot 5, Tango, Sierra Kilo, Burl in Dallas. I did see the movie.
Whiskey 5, Echo Bravo Bravo, David in Dallas.
Okay, good healthy start. We have N5HYP, Tom, KG5B, Mike, KE5ICX, Tom, KG5ZNJ, Frank, KG5OZT, Carolyn, N5BB, Bill, KF5TSK, Earl, and W5EBB, David. David, you did not mention whether you had seen the movie. Everyone else said they did. Did you see it?
Sorry, yes, I did see the movie. W5EBB.
Excellent. Okay, let's take Echo Link now.
Kilo Golf 5, Bravo Zulu Whiskey, Jerry near Weatherford. Yes, I saw it.
This Kilo Golf 5, Papa Mike November James. I did not see the movie. I'll just be listening. KG5PMN.
Let's see, where did we leave off? KG5BZWJ, who did see the movie, and KG5PMN James, who did not, and is just going to listen in. Okay, anybody else? Okay, well, let's talk about the plot. We'll start with Tom and Company, N5HYP. Go ahead.
Hey, this is November 5, Hotel Yankee Papa. Hi, Brenda and Company. I got on the list early because I want to get to bed early tonight, so wanted to jump in quick. Loved the movie. Great plot. Of course, Rod Serling wrote the darn thing, so you know, it had to be good. It followed some of the similar concepts that a lot of disaster movies like this, where you have a lot of people, you do try to get a little bit of background about the people, their families, their lives. But the story itself was very good. It was convincingly done well. The villain character was very well played. And I'll get into characters a little bit, but it does play into plot. I thought his demeanor and such drove the story well. I also thought that the tension between Ed Asner's characters and the FBI guy's character was very good. And you saw, and unlike a lot of procedurals that we have today, where, you know, the law enforcement people somehow just come up with this rather bizarre but off the, you know, off the cuff finding that helps them lead themselves to the criminal. In this case, really, it was pretty much the criminal's fault. The criminal's himself, the protagonist's own, you know, mistake of giving the number to the bartender guy that got him found. Although it was too late by that point. So anyway, really liked the movie. Thought it was a great story. Yes, I can see why the FAA would try to get television stations to not air it, because it would be an easy copycat. Heck, they even made a mention about Cuban hijackings, which were copycat type crimes as well. That's it for me for now. Back to net from N5HYP.
Okay, very good. KG5P, Mike, go ahead.
Thank you, Brenda. It's KG5P. Now, plot-wise, I didn't think this was one of Rod Serling's best. In fact, it's probably the worst thing he ever wrote. I think this was made about, was it made in 1966 or something like that? I mean, there have been airplane-type disaster movies for years. The first one that I remember was the one with John Wayne, The High and the Mighty, and there were several came after that. You know, I thought the characters were pretty, well, we'll talk about characters later, but I didn't think the plot really had much to offer. It was very predictable. In fact, now, I don't know if I've seen this movie before. Maybe I did, but I figured out the solution was early on in the movie. And I don't think, so I think I must have seen this before, because the solution was so obvious if you knew exactly what it was going to be. Denver, there are higher airports, a lot higher airports in Colorado than Denver, but they can't handle large aircraft. They're mostly, you know, for private aviation. Like level up in Ville, I believe it's 10,000 feet or something. So, but I remember flying into Stapleton. It was back before they opened Denver International, and you'd come in and be flying so low that you could actually look through people's windows. But I mean, I grew up in Denver, and that's 5,000 feet. So, it's conceivable, depending on where they set the thing to go off at, the altitude. So what I thought was interesting was they stuck the bomb in the pilot's map book, or map case, which was probably a pretty good place to do it. But I guess that's why they always tell you to, if you've left your carry-on stuff unattended at the airports, because they're afraid somebody's going to slip something in it, obviously. So, back to net, KG5P.
Okay, KE5ICX, Tom, go ahead.
Brenda, this film, I did remember the ending. I thought I had seen this film before, but it really was in the 60s when it showed up on regular television. I didn't see it in the movies in 1966, but I would say about 69. It was an NBC movie of the week, or not movie of the week, but TV movie. I remember later on seeing it that way, I guess. So I thought the story was quite interesting. I liked it. As with any film that's got a aircraft in it and in peril and in flight, you have your cast of characters that are always kind of wacky and over the top. At least no one sang, although I thought maybe Van Johnson might break into a tune, or Brigadoon or something, but he did not. He maintained his credibility and his capability throughout the thing. The landing in Denver, anybody who knows anything about anything with a bomb going off at 10,000 feet would say, hey, maybe I've got to land in Denver, and that was quite interesting. I like that part, although it was kind of obvious if you know those things, which I think most of us here do. I guess the case thing, the map case, is okay, but to me, I got to tell you something. I carried tool bag for years. I've carried briefcases for even more years. I even have a bag that I carry into my office every day with a computer in it. You know the weight of those things. And when you feel it a little light, you recognize it immediately. You go, oh, I must have left something at home. If it's a little heavier, you got to wonder, what's going on here? So it's a bomb. So it would seem to me that Van Johnson would have, the captain would have picked up on that a little more quickly. Thought it was an interesting idea. The whole idea of instead of having, and I like what was said earlier, what Tom mentioned is that in most police procedurals, there's some sort of remote thing that takes you from hundreds of potential murderers down to that one because you have to finish off the story in 44 minutes sans commercials. So that didn't happen here, which was good. And he ended up, the crazy guy ended up, which usually would have been played by Burgess Meredith, but he must not have been available. Time Enough at Last, I think is the story, or Time Enough, from that episode of The Twilight Zone. So overall, it was good. I enjoyed it. I'll watch it again. The plot was intriguing enough. I think it was a little thin elsewhere. There's, I don't think, enough of a story to really carry it for the 90 minutes that they wanted to run it. So I found my mind wandering at times. Jack Lord, though, well, I'll get to Jack Lord on the next round. That's what I got to say on this round. KE5ICX.
Hey, KG5ZNJ. Frank, go ahead.
That's KG5ZNJ. Yeah, I enjoyed watching the movie. It was just watchable for me anyway. I always like seeing movies from a while back that just sort of show how things were back in the old days, and obviously airports have changed a lot. So I always enjoy seeing that, especially that era. Just a cool era, the old days. The story, well, I mean, it was Rod Serling, the Twilight Zone guy. He's done those airplane disaster stories before, obviously, in the Twilight Zone there. What was that incident at whatever 1,000 feet there with William Shatner? So he's no stranger to it. So I don't know. I mean, it was fun to watch. It just played out pretty good, I thought. For what it was. It seems to me that it's definitely the prototype disaster movie of all the ones that followed in the 70s, because those became a huge thing. I remember very well. There were always TV movies, where like Lloyd Bridges is the airline captain, and there's always some, I don't know, maybe this is the prototype, maybe not, but I kind of got that feeling watching it. The briefcase thing that Tom said is very true. I carried a number of leather briefcases back in my government days in Canada, probably a good 5 years, and I'd walk miles with them. And because you're holding them in your hand, and they're heavy to begin with because they're leather, you feel every single ounce. And if anything's off, you'll know right away. There's no way you could slip in that device and you'd know immediately, trust me. Maybe if it was a shoulder bag, it might be different, but not one in your hand. So that was a little bit of a hole. The other weird, let me reset. I was going to say the other unexpected plot twist was that the bad guy wasn't outfoxed and outsmarted like normally happens. There's a big confrontation, and they they dramatically trick him. No, he just got drunk and died. So that was kind of a weird plot turn. But I guess it was interesting because it was different. I don't know what else. I mean, I think everybody else has pretty much covered it, but I did enjoy it. KG5, Z&J, back to net control.
Okay, KG5, OZT, Carolyn. Hey, I enjoyed the movie, and there was one thing in the plot that struck me is when they said everybody looking for the bomb, going through all the luggage and stuff. Well, it looks like that was pretty risky, you know, because, you know, that just struck me as an odd thing to do, although, who knows, maybe they thought that was the only way to do it, but, like I say, that was, struck me as odd, H5OZT. N5DB, Bill.
Hello, Brenda and team. This is N5BB. Well, good and bad things about the plot. Tom, I was confused by something. As you may have noticed, Tom said 10,000 feet. But of course, Denver is at mile high, about 5,280 feet. So early in the movie, I'm about 99% sure that the man, the Edmund O'Brien character with the thick, weird glasses. By the way, that was, if Tom says Edmund O'Brien just duplicated the normal Burgess Meredith character, I completely agree with you, Tom. I mean, it's everything. It's the thick glasses where he can't see very well. He's sweating. He has heart problems. He's a little bit disheveled. I mean, he just fits that whole character to a T. Anyway, but I'm really positive that he said that it was if they went, it was somewhere below 10,000 feet. Then near the end of the movie, mysteriously, the pilot somehow learns that the number is 4,000 feet. And I don't remember how that happened. I don't remember the bad guy telling the bartender 4,000 feet. If that was in there, I missed it. I think they cut out some things. I think they cut out some scenes where the 4,000 feet number was somehow discovered. And instead, near the end of the movie, they wasted time with read out the altitude to me in 1,000 feet increments, and then when we get below a certain level, 500 feet increments. They did that just to eat up time. And you notice the plane was going down awfully fast, and they were calling out 1,000 feet increments every few seconds, which I thought was also a little weird. But maybe they weren't really going down that fast. Anyway, so those parts of the plot where the 4,000-foot value came from, to me, was silly. Just like, I guess, Mike, I was thinking about Leadville, Colorado, which is probably too small a runway, but probably the only one that would have been close to 10,000 feet. Let's see. The airplane they mentioned was a 797, of course, which is obviously a take on Boeing's numbering system. And as you may realize, the Boeing 797 is the rumored nomenclature for the new Boeing midsize airplane, their midsize aircraft that's supposed to be unveiled later this year. which is just an interesting little note. What else? I guess that's it. The plot, to tell you the truth, was pretty simple. The Michael Saracen character, who was the corporal, was, of course, the standard movie deranged ex-Vietnam soldier that was deranged. But in this case, he miraculously became underanged. All it took was a good woman to smile at him and talk to him, and he suddenly turned it all around. That wasn't explained very well. And I guess we can talk about characterizations later, but the whole John Saxon character, the celebrity, was really overdone. In fact, BB.
Okay, this is WV5OZL. Yeah, if you search the 797 aircraft, you'll see a picture of it, or art. The next year or two, they're going to decide whether they're going to actually produce it, and if so, we'll probably see it. It'll probably see daylight in 2025. I don't know any real details about it. And yeah, Michael Saracen, to me, he's famous for being in the worst movie ever made. They shoot horses, don't they? Okay, next up, KF5 TSK Burl.
This is KF5 TSK. Well, let me start with the aircraft. It had a landing gear that was really the B-52. Had quad sets of wheels, but they always showed the 707. I enjoyed the movie. I thought I knew where it was going, but it was entertaining. I thought there were some things about the airline personnel that seemed to be overblown or overstated, and they were just so emotional about it, and really, well, like I said, I enjoyed the plot. I thought it moved well, but there were just some things that just seemed to be there just to take up time that, call out how many thousand feet we are, and, that had to be really, really boring. Also, the guy did tell the bartender that it was, 4,000, but there was nowhere we ever communicated that to anyone, so I don't know how that, actually happened. Overall, I said it moved along well. I enjoyed it, but, a lot of filler in between. KF5 TSK, back to net.
Okay, W5EBB Dave, go ahead.
Well, I found the plot to be very similar to Airport from 1970, and I really thought I was kind of watching the same movie. It's actually surprising that Rod Serling didn't sue, given the similarity of the story. The FAA directive or request for TV not to broadcast this particular movie because of the copycat activities was issued in 1971, and Airport came out in 1970, was a very successful movie, and the highest grossing movie for Universal Pictures at that up until that time. I suspect it was due to the success of Airport, not this movie, that the FAA directive was issued. So I suspect that Wikipedia section about this 1966 movie being the cause of the directive made in 1971 is a bit dubious, a little specious. but that's what you get from open source encyclopedias. And it did not seem like a Rod Serling story. It didn't have the edge, the insights, the smarts of most of his stories. But the movie did have a few of his timeless trademark Easter eggs, like the many shots of wall clocks, some of them apparently broken and showing incorrect time. An aneroid bomb with relays set as a function of pressure, air pressure, would not work in a pressurized passenger cabin. It would have to be placed in an unpressurized part of the plane, which it was not. It was in the cockpit. So the air pressure should not have changed very much. It's basically as if you were at the same altitude you were at takeoff. So that's where the plot just totally breaks down. And I think Rod Serling should be a little smarter than that. And incidentally, Bill, yes, at least in the version of this movie that I saw, the bomber did in fact mention 4,000 feet in his drunken stupor. So he said that as he was talking to the bartender, and the bartender must have conveyed that to Mr. Hawaii 50. W5EBB.
KG5BZW is Jay.
This is KG5BZW. Yeah, David kind of stole my thunder on the one thing that really did annoy me, which was the fact that it's the air pressure. Okay, let's just put it this way. The air pressure in a pressurized airplane is not going to be the same as where you took off. It's going to be, kept to a certain altitude. But the altitude that I think they mentioned, I think the man mentioned was like, what was 9,500, 9,000 something. The air pressurization of cabins is, at least these days, typically to the point of, I had to look it up because it's like, there's a certain range where this could actually work. After I had thought about it and was first annoyed, like, no, this is stupid. This is not going to work. So if I saw that some airlines had it to like a minimum of the air pressure at 8,000, some had for the pressure at the minimum of 7,000, so a little bit higher. But so if you stayed above if you had a trigger level that was like, I don't know, 6,000 feet, and the second trigger was at 2,000 feet, yeah, that maybe could still work, but I don't believe that, as described in the film, it would work. So yeah, that was my big first thing that kind of annoyed me. Then reset. Second thing, I could not enjoy the film. As I guess some others mentioned, there's a lot of I don't know, plot device. Movies that stole the same, similar, I don't know, plot devices or whatnot. And of course, I've seen the movie Airplane, which seemed to make fun of all of them, and certainly it seems that several of the plot items shown in the film were indeed made fun of in Airplane. So it's like, well, I've already seen Airplanes, so I've already seen, like, I don't know, a third of this. It's just, yeah, I think having seen Airplane just kind of ruined this movie for me. But at the same time, I mean, I won't say it's like horrible, but I don't know. I had to speed the film up. I didn't learn, but you can speed up YouTube films on your phone and on desktop. So I used that to get my way through it. Parts of it were good. Parts of it were just, I don't know, just felt like it took itself just a little bit too seriously for my taste. Yeah, and I think the other things I was going to say has already been taken care of. So I'll turn it back to Net Control. This is KQ5BZW.
Thank you, Jay. Well, I really enjoyed the movie, despite some of the problems, plot holes, and inconsistencies. I think the plot was serviceable. It wasn't, this is not a masterpiece, but it was a made-for-TV movie, and that just automatically suggests something that's been dumbed down. I agree. It doesn't have quite the edge that you'd expect with Rod Serling's Twilight Zone. And those stopped in 1964, so this was 2 years later, and somebody may have said to him, you need something a little more mainstream than what you're used to. I don't know. So it's hard to say. Very good. I love the music. Music makes you think you're watching Twilight Zone. And by the way, pilots, carry those big black bags anymore. Those things are heavy and they were a real burden, and they now use electronics to do their navigation. Okay, any more check-ins? Okay, none heard. Let's go back to the top, and we're going to talk about characters. N5HYP, Tom, do you have any?
There's N5HYP. Yeah, characters were a little bit on the thin side, but yeah. And again, this was a made-for-television thing. They only, if it was to fit into a 2-hour slot, you really only had 90 minutes content. And so that tends to limit what you can do with characters. Somebody mentioned, I think it was Bill, mentioned the military guy. I thought, okay, well, this is a guy who had PTSD, but of course they didn't know to call it PTSD back then. But you had the flight attendant, the stewardesses back in 1966 were just glorified waitresses, so they were depicted that way. Ed Asner and I think both of them are decent actors, and so they've filled their characters well. Just again, television in the 60s was very controlled by the censors of the network, and there was a lot of, I'm sure, as somebody else said, oh, yeah, dumb it down a little bit. Let's just make a good made-for-TV movie with really big text on the credits so that everybody with their fuzzy televisions could read it. That's it for me for now. This is N5HYP. Back to Net.
Okay, KG5P. Mike, what do you think of the characters?
Okay, Brenda, it's KG5P. Well, before I got to characters, I want to comment on some of the other things, because a lot of good, interesting topics were brought up. That movie, I think that Tom had mentioned, Time Enough at Last, with Burgess Meredith. Actually, I had to look that up. because I thought Edmund O'Brien was in that one. Because I could have sworn that it was Burgess Meredith or Edmund O'Brien was in Time Enough at Last. That's interesting. Twilight Zone movie, if you ever get a chance, is about this guy with a henpecked wife, and he likes to read, and so he works for a bank, and he goes in the bank vault and shuts the vault door so he can read and eat lunch, and then World War III breaks out, and he comes out, and he's the only one left. He says, well, at least there's time enough at last, and then he steps on his glasses. He had the Edmund O'Brien type glasses. Burrow had mentioned that B-52 landing gear. I'd forgotten about that, but I was going to mention that too. Yeah, you'd see the landing gear. Instead of they showed the passenger plane, but then the landing gear was for a B-52. Back in the late 60s and early 70s, and I forget the exact years, but around that time, there were a lot of people hijacking planes. I mean, hardly a month went by without somebody hijacking a plane and going to Cuba. And then it got so bad that people they got on a plane to Cincinnati and they'd hijack it to Cleveland or something like that. So there was definitely a lot of copycat stuff going on. The 25 ABB had talked about the pressurized cabin. They pressurize passenger planes at around 10,000 feet, not at sea level. So the thing we're in the cabin, it would have to drop. The pressure would have to drop below 4,000 feet or wherever the bomb was supposed to go off at, and to keep it pressurized and get everybody up the plane in Denver, which they couldn't be difficult to do, I suppose. But also, they didn't know that the thing was in the bag. It could have been, in some other part of the aircraft. Typically, the whole aircraft is pressurized, including the baggage compartment. So it did make sense there too, but it wasn't quite as bad as Dave thought, because they don't pressurize those at sea level. I guess that was about it for that. The characters, I think they could have done without a couple of the characters, like the old lady. She didn't really add anything. She was writing out her will. Well, why, is your lawyer on board the plane or something? Are you going to give it to your lawyer? I mean, the plane's going to crash and you're all going to die, so take the will with you. So what's the point of writing out your will? The worst character in the whole movie was the John Agar, a.k.a. Mr. Shirley Temple. He really overplayed that role. I guess maybe he was supposed to. But then, of course, at the end, he was, making himself out to be the big hero. And, of course, everybody knew he was a jerk. And the real hero was the PTSD soldier. But like I said, they didn't call it back then. It was, the other characters, the Jack Lord guy, he was pretty generic. Not long out of his Felix Leiter role. The Van Johnson guy, he was pretty bland. The best actor in the whole movie was the crazy Edmund O'Brien guy. It just was not up to, and the characters were not up to typical Rod Serling, so I was kind of disappointed in that. Back to net, KG5P.
Hey, KG5ICX. Tom, go ahead.
I think we killed killed the characters off pretty well, even though they all landed successfully. I'm going to diverge, since I don't have anything on that, just a technical thing involving aircraft. The bomb, as was mentioned earlier, that would have been a problem. The bomb would need to know altitude. And the aircraft, most aircraft, modern aircraft, you'll see this if you look at them, have what are called static ports. They are these silver discs you see on the left and right side of the airplane. There are a minimum of 3 of them in the aircraft, one on the pilot side, usually one on the co-pilot side. And then there's one inside the cockpit or the flight deck itself. Should the flight deck become depressurized, you can actually, or if you do it on purpose, you can figure out what your actual altitude is. The static ports determine how much pressure there is. There was an aircraft that had crashed at one, I don't know, probably about 30 years ago, because the static port had been covered over. It is aluminum. It's made out of aluminum. There's 8 small holes where air comes in, and it is usually moved someplace on the aircraft where there isn't a lot of turbulence, so that you're able to figure out actual altitude or pressure. So, as it's got to be external to the aircraft, obviously. It's got to be on the skin. Oh, I was going to mention about the crash. Somebody had covered it over with tape. They painted the aircraft, and then they forgot to remove the tape. And as such, they were getting wrong indications as to how high, what the altitude of the aircraft was. So that third static port is in the cockpit. It is somewhere inside, but obviously it's worthless unless it's depressurized. So I thought I'd mention that. As far as characters, I agree with everyone else. Yep, they were mostly thin. I thought John Saxon did a great job of playing John Saxon. He really is like that guy. So, he's one of the weirder people to ever be in TV and motion pictures. And I did mention he was the guy I was alluding to in my reading as the guy in the failed Gene Roddenberry Genesis 2 story. And he plays John Saxon once again. So, other than that, I don't have much to add that hasn't already been said about the characters. So I yield my 5 minutes back. This is KE5I6.
All right, Frank, KG5ZNJ, go ahead.
KG5ZNJ. Well, I thought the worst actor, maybe not technically the worst, but the one that grated me the most was just the captain of the airplane. He just was overacting so bad, it was painful. Ed Asner, that was probably the youngest and the youngest and the thinnest version I've ever seen of Ed Asner, so that was kind of funny. And I just think him as Lou Grant, and I never liked him, so I don't know, it's just kind of comical, whatever. The Edmund O'Brien, I liked him. I thought he played a great psycho, even if he was copying Mickey. But I'll tell you what, he plays a good drunk, and to me the sign of a really good actor is a good actor who can play a good drunk when he's sober. That's one of the more difficult things to do, and he played it really good. He played a good drunk, and he seemed to me like he was really drunk. So either he was or he's one heck of a good actor, and I kind of think he's a really good actor, so I liked him. Now, that leads us to John Saxon. Well, John Saxon doesn't do half measures. You always get the extra mayo, man. That's John Saxon, and he's hilarious. He's like one of those signature bad actors of the 70s, and he's great. I think probably his best role of his career was in The $6 Million Man. If you remember that, he had two good roles. He played the robot, which was known later as Maskatron, and if you remember the scene with Lee Majors and Andre the Giant, where Andre the Giant was Sasquatch, and you had John Saxon in the background going, "Sasquatch, kill, kill!" Man, that's just the best thing ever. Here's the thing I didn't understand. I was expecting John Saxon to get punched out at the end by the Vietnam guy. That would have been the standard script. He's coming off like a total jerk in front of everybody and big time and everybody in front of the cameras, and then you'd expect the veteran to go up to him and just punch him out, and then walk away with the pretty stewardess. And that didn't happen. I was shocked. That should have happened. Whatever. The bartender, I don't know why, but that guy was so familiar, and usually I'm really good at placing familiar-looking people. I couldn't do it. I just know I've seen him before, and whenever that happens, I always think he must have been a character on the old Star Trek series, like just one of the incidental characters in 1 or 2 episodes. But he was very familiar to me, and I just can't place him. It's driving me crazy. Lalo Schifrin did the soundtrack. He's one of the greats. That's why that had a good soundtrack. You know, he did all the good soundtracks of the 60s and 70s. I don't know, other than that, I just thought of this. Speed ripped off this movie pretty good. Anyways, that's all I got. KG5ZNJ, back to net control.
Hey, Carolyn, KG5OZT. I agree with a lot of that. One thing, did you notice not too many women characters? It seemed like you would expect more. Where's what? Seemed like I counted 4 stewardesses, the old lady, and the executive's wife, and I don't remember seeing too many other women characters in there, but I might have missed them, but versus at all seemed almost alike, of course, all in orange, but anyway, it seemed like it was characters were men. KH5OZT. N5BB, Bill.
This is N5BB. Well, to answer a question, the bartender was Malachi Throne, who was a character actor that was in just about everything back in the 60s and 70s, 80s. He was in the 2000s. He was in Star Trek things. He was in Batman movies, Babylon 5. He was in the Star Trek and Next Generation, Law and Order, Streets of San Francisco, The Wild Wild West, you name it. So he was everywhere. So, yeah, he was just all over everything. I think he did a good job. Other characters. Edmund O'Brien, as I mentioned earlier, I thought he did what he was supposed to do, although it was played pretty thickly. He laid it on pretty heavy there, especially when it was drunk at the end, but I think he did a good job. I think the story was kind of silly that he died. And the thing I forgot to mention earlier on the plot, the fact the delivery car driver died. He seemed to be a happy-go-lucky guy that was speeding or something. That was just a little extra plot thing that was over the top, you know. Why did he die, and why did Edmund O'Brien also die? That's not very likely. That's just pretty over the top. Anyway, going back to the plot, Ed Asner was like 37 years old or something. You know, he had been in around the movies and things over a decade. So he may look young in this, but he'd been around the industry for over a decade. He was like 37. Did you notice Greg Morris, Mr. Mission Impossible, and other stuff? Greg Morris was in this as one of the FBI guys helping Jack Lord, acting his normal, cool, collected self. He's always Mr. Cool. And again, as Tom said, Michael Sarrazin is always, he plays a number of rather over-the-top characters. He's always incredibly emotional. He's that kind of bothered character. I think everything he's played, there was something a little bit wild and crazy about his facial expressions. Van Johnson was at the peak of his career. He was over everything. He was in all kinds of entertainment, you name it. So he was at the peak of his celebrity when this movie was made. And as people said, John Saxon was over the top in so many things, and he couldn't have been more over the top in this thing. I agree. Somebody should have smacked him and handcuffed him or done something. He was obnoxious. The female character is a very sexist movie. I mean, it was made in 1966, and you notice that the flight attendants were treated rather rudely by everybody. You know, just give me a coffee. Shut up and give me a coffee, or et cetera, et cetera. People kind of bark commands at them. And let's see, what else? Jack Lord played Jack Lord. It's like Hawaii Five-0, the same kind of character. Mr. Cool, collected, smart agent. Anyway, I guess I thought the characters were pretty well defined right there. I didn't exactly understand. Well, the Jack Lord's wife that was on the airplane. Again, why did they throw that in? That wasn't really needed. And they didn't do anything with it. He didn't talk to her on the airplane or anything. She just broke down when she landed. You know, she was playing at that time, the female role of the females break down. And the woman next to her, of course, writing her will, was also acting a little over the top. So what I'm saying from all that is there's a lot of stereotypical behavior they stuck in here. But it was a 1966 film. That's all I got in 5BB.
KF5 TSK World.
That's KF5 TSK. Well, one of the things that bothered me about the whole film was searching for the bomb that, you know, they went to the luggage compartment and only did that in 10 minutes. And now we go to the passenger compartment, and the way they were opening up luggage and just dumping it out, I mean, if it really was a bomb, you probably could have set it out just by dropping it on the floor or whatever. The other thing that was unusual is you have an axe on the airplane with the 10 of meat. And, you know, also taking the axe to the airplane, that, you know, you start swinging the axe, you don't know what's behind the panel, you know. Could be electrical. You might hit something hydraulic. You know, you could cause far more problems, and some of the flight crew shouldn't have known that. Other than that, I thought it was a good movie for the time. It, you know, kind of moved along and probably had all the necessary pieces, but, you know, it was 90 minutes, so what do you really expect? KF5 TSK back to net.
Okay, W5EBB. David, what did you think of the characters?
Well, just pretty much the same as what everybody else has said, but it's kind of an ensemble cast, you know, very similar to all of the airport movies and airplane movies. But there are also some parallels between airport and this movie in some of the characters. Now, Michael Sarrazin, who I'll call Corporal Frankenstein, the true story, was married to Jacqueline Bisset, who was in Airport. Celia Lovsky, also known as T'Pau from Time Amok, the Star Trek episode, the Vulcan. Apparently she was making a connection at JFK, New York, to planet Vulcan, I suppose. She also was in Airport, apparently uncredited. And, her character, she was a wealthy older woman, and her character is very closely reminiscent of Airport 75's Gloria Swanson. And I'm not sure, I haven't seen that movie lately, but I think Gloria Swanson was working on her will in that movie too. So it's no surprise that I felt like I've seen this movie before, even though I'd never seen it. Let me reset. Now I was just looking on doing some online research, following up on that FAA request to not show these movies on TV. There were, and again, this is the reference I'm looking at, 160 hijackings of U.S. aircraft, passenger aircraft, between like 1966 to 1973 or something like that. And it reached its peak in 1972. And guess what? There was a movie released called Skyjacked in 1972 starring Charlton Heston. So life imitating art, art imitating life. Yes and yes. W5EBB.
Okay, KG5BZWJ.
This is KG5BGW. I don't know if I really can say anything in addition. Character-wise, I mean, yeah, that captain, the obnoxious John Saxon's character and the overacting of the captain just kind of drove me crazy. I'm kind of glad for the calm, collected Jack Lord character and other characters that were featured that at least took the edge. Well, I don't know, maybe edge is not the right word, but at least somewhat balanced it out. I like the mix of actors, and I think the besides those two, it really wasn't that bad of a mix. But a lot of the stuff that kind of just drove me over the edge, as I already mentioned. One quick thing, but I'm not quite sure, because I can't really say what commercial jetliner does, but anyway, let me reset. I guess I just wanted to make brief mention, you talk about altimeters and standard air pressures. Well, of course, you have to deal with the fact that you have low pressure systems and high pressure systems. And I've always kind of wondered what a commercial airliner does with regard to that, because they travel so far and so often that calibration in one place doesn't really make sense in another place, so it might really be different for a aircraft, but it doesn't really matter because the bomb would have to be calibrated to work wherever as well. So, if you have a low pressure system, or excuse me, a high pressure system at 5,000 feet, I almost have to wonder, that might still be enough to make make the bomb act like it thinks it's at 450 or something. I don't know. I'd have to do the math I don't even know the formula. I just know that you get up in altitude. Air pressure does have a way of I just know that. Let's just put it this way: my dad was a private pilot, and he always had to calibrate his altimeter, no matter where he was, for the air pressure that day, that time, and clearly that's one of the things that had to be in respect to that bomb. I'm misstating that, but a factor, I should say. Anyway, I know that's not character, but I would just have to add that because I wasn't adding anything else. Anyway, KG5BZW, back to that.
Okay. I don't have a whole lot to add to the characters. I think this horse has been flogged sufficiently. So I'm just going to pass on this. Anybody else want to join this net? Please come down. Hey, there's not much to say on special effects. It really was not a science fiction movie, and there wasn't any. Like virtually every airplane movie I've ever seen, they do mix interiors and exteriors or landing gear. They're not consistent. They don't bother to try and learn, or they think that we don't know the difference. Imagine that. Okay, I think what we'll do is if you have any more comments, just please go ahead and give your call sign, and we'll go back and you can talk about anything you want to talk about. So go ahead. Oh, looks like interest is waning. Well, I guess we will close the net then. And unless there's anything else anybody wants to say, go ahead.
Jay, just wanting to know what the movie is for next week.
All right, well, let's move on to that. KE5ICX, do you have some information?
Yep, I do. Back to science fiction. This one is Gattaca from 1997. I don't know much about this film. I've never seen it, but it is available. Go to the Afro Movie Facebook page. You'll find it there with a link. And if you're on or if you don't do Facebook, or you're not part of Afterglow Movie Facebook page, I'll send it via email. If you would like to receive it and you haven't received those updates, just send an email to KE5ICX, Kilo Echo 5, India Charlie X-ray at yahoo.com. Say you'd like to be added to the list. Otherwise, you'll get it sometime tomorrow morning. That's it for me, KE5ICX.
Tom, well, we had 11 hams participating tonight. That includes me. So we're going to wrap this thing up at 23:45. And this is WV5OZL. Clear.
ICX W5 EBB.